The switching back and forth between forms. Yeah. Radical form and exponent form. Alright, so we're going to be in 2.8 today, which is going to be on page 33 of your white packet. There are, it says it's 2 problems, but really it's 5 problems to do on that one. So I'm going to give you like 10 minutes to find me the arithmetic numbers that fit in between there, okay, and the geometric numbers that fit in between there. There are enough for both on those, and then find me an equation for each of those linear relationships in numbers 2, 3, and 4. Okay, Candle, get at it. So for an arithmetic, we take the last term, we subtract off the first term, and then we divide it by the number of jumps. In this case, we had 3 jumps. So 48 minus 6 is 42. 42 divided by 3 is 14. So we're adding 14 here every single time. So 6 plus 14 is 20. 20 plus 14 is 34. 34 plus 14 is 48. So it works out. Okay. For geometric, we take the last term, we divide it by the first term, and we take the root of the number of jumps that we took. 48 divided by 6 is 8. And the cube root of 8 is 2. So we're going to multiply by 2 every single time. So then 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. Questions on those 2? Okay. Linear relationship for the problem below. So f of x here would equal my rate of change here is plus 3. So that would be 3 times the quantity x minus negative 7. So that would be plus 7, then minus 35. Or 3 times x plus 6 minus 32. Or 3 times negative, I put negative 5 in the wrong spot. 3 times x plus 5, then minus 29. Or 3 times x plus 4, then plus 26, and so on and so forth. Or, simply put, 3x minus 14. All of those simplify to be 3x minus 14. Over here, we could have had f of x equals, this one is minus 6, minus 6, minus 6. So then we would have negative 6 times the quantity x minus 7 plus 27. Or we would have negative 6 times the quantity x minus 8 plus 21. Or we would have negative 6 times the quantity x minus 9 plus 15. Or we'd have the quantity negative 6 x minus 10 plus 9. Or, simply put, we would have f of x equals negative 6x plus 69. No. 10, 9, 69? 69. Oh, yeah, I was doing negative 6 plus negative 9, like 15, 30. I'm like, wait, yeah. No, yeah, 54, 69, yeah, plus 69. Okay. On this one, we need to find the slope of the line. It appears to go through this point and this point. So that gives me a rise of negative 2. That gives me a run of positive 4. So my slope is going to be negative 1/2. And it goes to the y-intercept of positive. Questions, comments, concerns, clarifications? Could have also made a table out of that last one too if you wanted to, okay? And then work our way back from those. We're working our way towards getting away from these up here. Working away from getting away from these and going more into those. And those simplified ones. That's our goal, is to get it nice and easily simplified. And so we're working towards that with every bated breath. Okay? Okay? So, let's talk here now on page 34 about Calcurama and ComputerFest. Okay? So Calcurama had a net income of $5 million in 2020, while a small competing company, ComputerFest, had a net income of $2 million. Okay? I don't know why the millions are in italics there. Or italicized. Makes no sense to me, but I smile and I nod. The management of Calcurama develops a business plan for future growth project that projects an increase in net income of $0.5 million per year, while the management of ComputerFest develops a plan aimed at increasing its net income by 15% each year. Okay? So based off of just that, what can you tell me what kind of model, if you will, would Calcurama be? Which kind of a model would Calcurama be? Or, for that matter, the follow-up question that is, what kind of a model is ComputerFest going to be? Based off of what you've learned this entire year here in Math 1. Calcurama, what kind of a model? What are our two types of models? What do you got, Cam? Calcurama's geometric, says Cam. Do we agree with Calcurama being geometric? Reread the problem if you need to. Cam, I do not agree.
Oh, I was looking at
ComputerFest? Why is ComputerFest geometric? I'll go off of that one for you. Because it's got a percent, right. So this one is going to be geometric. because of the percent. Yes, ma'am. Per year. So every year it's going up $500,000. Yep. Okay. Yep. And so then this one would be arithmetic. Because it's always going up by that same every single year. Okay? What I want you to do now is I want you to come up with well, first off, I would start actually in reverse order. I would first come up with the table of values first, then come up with an equation for both of those. Okay? Go for it. Agree with my table for Calcurama. Yeah? Yep. So then your Calcurama equation should be, actually here, let me put it in function form. Income of x is going to be 1/2 x plus 5 when you're done with it. Because we're always going up by half. That's where the 1/2 x comes in. And our y-intercept was 5. That's where our 0 x value is. Okay? $2.3 for the next one. 2.645. .04, we'll call it 2. Really, it's 3.04175. Yes? Okay. I got an equation here of, we can't call it I, so let's call it money. M of x is going to be 2 times 1.15 to the x power. Agree with me on that? Or you could have gone 2.3 times 1.15 to the x minus 1 power. Okay? Yes? Now, let's compare those. Do you have these written down? Yeah, okay, good, because I'm going to borrow them here momentarily. Or I'm going to make you read them off for me, I should say. So let's just, I'm not going to have you guys graph these. I'm going to graph them for you here on the old Desmos. Okay? So we've got 0, 1, 2, 3, 4, 5. How many years did we go out? 6? We only went to 5 years? Okay. And we started at 5, and then we went to 5.5, then we went to 6, then we went to 6.5, then we went to 7, then we went to 7.5, right? Okay, I love it. Okay, So there's that one. Then we said that this was y equals 0.5x plus 5. Hits them all. Love it. Okay? Excited to be part of it. Next one, we made a table, and we went 0 and 2, and then we went 1 and 2.3, you said? Okay. Then we went 2 and 6, 4, 5, and then we went 3 and 4, 1, 7, 5. Okay. All right. So there we go. And we said that that one then was y equals 2 times 1.15, and then now I gotta get my thingy, to the x power. Yes? Okay. Oops. So if you wanted to sketch those graphs, you could sketch those graphs right now. You can put them both on one if you want, or you could split them up if you want to split them up. But sketch those graphs at this time. Dropped it in there, so then this one, what was the first company? Calculitech? Calculorama. Okay, so this one here is Calculorama. And then what's the other one? Computatech? Computafest? Okay, so that's what those two are. Okay? Alright? So, the first question that it's asking us is to compare these two companies. Talk to me. What do you see? They're both increasing. Is that good or is that bad when we're talking about a company?
Good. That's good.
Well, it depends on what we're talking about, right? Well, okay, so why is it good?
We get more money.
What's going up, though? Their money that they are making. So their income is going up, which is always good when you're talking about a company. Yes. That was your add. Okay, right?
One's linear and one's not.
One's linear and one's not. Okay, all right. So let's talk about that for a little bit. What are you thinking about there? Well, we got to compare the. Yeah, one is linear. The arithmetic one is linear. The geometric one is not. Okay. So what does that mean?
The Calculorama is increasing at a constant rate and Computafest isn't.
Okay. Anything else to add to that? Based off of visual? Brady, jump in.
Well, Computafest started off with a lower income. Eventually, it's going to be making way more than Calculorama.
Okay. All right. After like what appears to be after like 12 and a quarter years, it catches up and then now it's making more. Love it. Okay. Anything else? No? Okay. All right. That's a good comparison of the two. Now I've got to copy that. Okay. If both companies were to meet their goals, which means they kept going along this path, or they followed this one, which company would you choose to invest in? Which company would you choose to invest in? Computafest? Okay, why?
Because it's increasing faster.
They're going to be worth more money
Yeah.
after, in the long run? Okay. Anybody else got another idea? Yeah. It's just, well, no, Calgary is always going to keep going at that $500,000 a year.
Oh,
Computer Fest is gonna take off.
oh yeah. I didn't want to just like go up straight. They just do the same.
No, they only make the same at that point that I've got labeled right here. At that point.
Yeah, but like won't CalcuFest just like make
Because we'll make so much money that eventually it turns straight up? Is that what you're saying? Eventually. But that's way, way down the road. Okay? Anybody got another thought on how to invest your money? Don't get me wrong. I agree. Over time, Computer Fest is the better investment.
But like if it's only for a little bit of time, then Calculamo be better because it's like higher.
It's worth more. Yep. And the short. So if you're going short-term investments, which a lot of people do short-term investments for, then you would want to be Calcurama. But if you're planning on investing longer than 12 years, then you want Computer Fest. Okay? Definitely. I would concur with that. I'll bring the graph back over here again. Okay? If ever, would your prediction suggest that the two companies have the same net income? When would they have the same net income? In this one right here? In the 12.29179?
Yeah.
I would go with kind of like end of February-ish, yeah. What would that actually be? There. 0.29179 times 12 would be, actually, no, it's middle of March. Yeah, middle of March. Okay? How do we know that? How do we know that that's where they are going to? Because that's where what? That's where they intersect. Yep, exactly. That's okay. Intersect, same thing. Okay, that's where they intersect. Okay, that's where they cross each other. Yep. After that, will they ever have the same income again? Unless one of them unless like Computer Fest takes off, or wait, which one? Unless Calcurama really takes off and Computer Fest falls off, right? Okay. Yep. So we're assuming that won't happen. Okay. Since we are creating models for these companies, we could choose to have a discrete or a continuous model. Which one do you think best modifies? So the discrete model would be all of the dots. The continuous model would be the line and the curve. Why? Okay. 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 Because we can have half a year and we can have half a dollar. They're making money the entire year. Yeah, I would agree.
So like kind of like off that, so like you can like see how much money it'll be like halfway through the year.
Yeah.
Which is like what you said. Like,
Yep. Nope. Exactly. Okay. I will tell you right now from personal experience. Okay. For those of you that don't know, I run a small farm. Okay, on the side. Okay. I don't have a continuous model for my profits working on my farm. Okay? Because I only get paid once a year. Okay? It just so happens that the two people that I sell my products to pay me at roughly the same time. So I only get paid once a year. So mine, Lindsmeyer Farms, would be a discrete, would be a better model, a better prediction my income. For these two companies that are selling things year round, definitely continuous. I would agree. Okay? Alright? Let's talk domains here. Actually, the domains for both the same? Are the domains for both the same?
Yes.
Yeah, they are. Okay? So what would they both be? They're both all real numbers. Do they have any restrictions or conditions associated with them? Big hint that I put after my funky R.
Yes.
They do. Okay, what would it be?
0.
What about 0?
They started at the same time.
You do realize that there's a whole table up here that you can put your paper on. And then switch with Kale.
And then to like,
I know, but then she can't look at you guys and talk to you the whole time. I get it. I know what's happening. You think I don't know here, Barwick, but I know, okay?
He knows
who
well.
actually like figures?
Okay, that was what we call a distraction in the teaching business. So what is our restriction here on this domain? What do you got?
Yes.
So can it be equal to 0? Yeah, it can. Because we have 0. If we go back a slide, if you guys look up on the last page, we have 0 in our chart, right? So it can be equal to 0? Okay, so here then we would say x is greater than or equal to 0. Okay? We are going to start expecting not just all real numbers, not just naturals, not just wholes. We're going to start expecting if this is a classification type one where you need to have a condition to go along with it, we are now going to be expecting that condition to be there in order for you to get the points. Okay? Alright? Love it. Homework this evening is in your blue packet on page 27 in your blue packet. Okay? Problems 1 through 21. I am open and available for stamping and all of that fun stuff. Just as an FYI, tomorrow you will be having a quiz. Okay? What?
It's on this.
It's going to be on everything so far, yes, in Unit 2. Okay? Yes.
Oh.
Okay? Right? Then, looking forward, you will have a test next week, Thursday.
Got it.
Okay? We'll have a test next week, Thursday. So quiz tomorrow, test next week.